Let's learn how to do what's called the difference of two squares. In a lot of books, maybe 15 years ago, they would teach this factoring first, and I thought that was a pretty good thing that they did. There was one book where they made students recognize a pattern, and I don't know, maybe your book doesn't do it, but let's just look for a second at what if you have two quantities that are multiplied together and they have an x in one of the factors and the other number is the same number except one is plus and one is minus. Watch what happens when you multiply this. Maybe your teacher has called your attention to it. First times first is x squared. Outside is plus 5x. Inside is minus 5x, and last times last is minus 25. The middle terms kill each other off. Oh, does that happen every time? Let's think about it. What if we had an x plus 3 times an x minus 3? I bet you're already telling me. It would be first times first, x squared, outside minus 3x, inside plus 3x, minus 9. The middle terms kill each other off. So I think we could generalize, or you could practice some more yourself. If you have two binomials that multiply and they have the exact same numbers but a different sign between them, when all is said and done, the middle term gets killed off. So this makes it easy when we go factoring, because if we have a problem where there is no middle term, we know where it had to come from. In fact, it's so easy that you could probably do this right now. X squared minus 9 must have come from two quantities that were exactly alike except for the sign in the middle. One was plus and one was minus, x and x. And what number gives you 9 where the two quantities are the same? Well, it's 3 and 3. So this is x plus 3, it doesn't matter whether you do the plus or the minus first, and times x minus 3, we win. I did the Wright brothers here. They probably saw this pattern right off because they were pretty clever at observing things. Let's do a new problem. Oh, no middle term. Where would the 9 come from? It has to be the same number in both quantities. It would have to be 3x times 3x. Where did the 4 come from? It has to be the same quantity in both terms. Both quantities, both binomials. It'd be 2 times 2, so this would be 3x plus 2 and 3x minus 2. Watch the Wright brothers. They're going to make another airplane. We win. Oh, what's this one? Ah, x plus 1 times x minus 1. Too easy. We won't even mess with it. What's this? 3x plus 2, 3x minus 2. What's this? 5x plus 6. And go on the negatives now this time. 5x minus 6. Look, the middle terms kill each other off. That's the way the pattern works. This is called the difference of two perfect squares. Practice till you never miss it anymore. We skipped over that in the trinomials ones. When you see two terms, the middle x to the first power term is missing, you know that you have the difference of two perfect squares that you can deal with, and you have two quantities that are alike except for their sign.